What is good, guys? Today uh, we're gonna be solving encode and decode strings. Currently, it is 12:25 a.m. It's kind of late, but you gotta grind that leak code. Go find some music to play real quick, and then we'll get right into the code. Um, I like this song. This play track was good. All right, get some lo-fi. Okay. Go ahead and solve it. So we have to design an algorithm to encode a list of strings to a string. The encoded string is then sent over a network and decoded back into the original list of strings. Okay, so an example could be let's see, machine 1, the sender has my function. Machine 2, receiver has the function. Machine 1 encodes the string. Machine 2 decodes it. So kind of just it makes one long string, right? Okay. So let me just kind of write it out. So we are given a list of strings, and we want to return a single string. A single string of all of those strings combined. All right, let's go ahead, and I think we should just, we should, I would say go through each string and append it to like an answer or something, to like result to a master string. I'm thinking we should have like some sort of delimiter. We should have a random symbol. I'm gonna just say like hashtag would be good. We should have a symbol to separate words. Yeah, okay. That would be pretty good. For example, if we had hello world, let's go through an example. Maybe we had something like, let's go just get this. It would say something like, hello world. So each time we hit this symbol, we know that it's the start of a word. But I think the edge case is that when we check for this, let's say this is in the string itself, right? Let's say if the word was hello world like this, how would we be able to tell the difference between that symbol, that hashtag symbol, being at the beginning of a word, or it is the word? You know what I mean? That's why we have to get the count of each letter. For example, let's see, this is letter, 1, 2, 3, 4, 5. The length of hello is 5. So we would have hashtag, we had to have 5. Hashtag, then hello. Okay. So for example, this would be world. World would also be 5. So we could separate the words like this, or we could go ahead and combine them like that. Separating them, we have to find a way to do that. Initially, I would say go through the loop until, okay, so we'll start at 5. Right, we could assume that the first letter, or the first character in the string is going to be an integer, because we're the one that's encoding it, because we're defining encode. And when we read 5, we know that we should turn the pointer 1 to the right, iterate 5 times, 1, 2, 3, 4, 5. And when we go the 6th time, we're going to reach the next letter again. And from there, we could go read those numbers until we hit another hashtag. So for example, if we had something that was length 10, okay, so 5, we'd go 1 to the right. We'd read it 1, 2, 3, 4, 5. Then we know that's the end of the first word. We go ahead and separate it. Then we just go count the numbers till we hit the hashtag again. Once we hit the hashtag, we know that this is 10, so the next word will be 10 letters long. That's the theory of it, and let's go ahead and make this. Go ahead and encode now. So let me go ahead and write this down for this. For decode, we will start at the number at an integer. That integer will tell us how many letters our word is. We read that integer until we reach our delimiter. In our case, we're going to use the delimiter hashtag. I think this should be a pretty good algorithm. Let's go ahead and try to actually code it out now. So let's go ahead and code it out. So how do we encode it? First, we got to get the length of the word, so we could say for each word in STRS. Get the length of word. We'll go ahead and store that in front. So let's see. Let's store that in front. So I would say we'd have something called master word, which is equal to an empty string at first, and we could just say length of word, say string length of word, because we want to go ahead and turn this into a string. So we do master word plus string length of word plus the hashtag our delimiter and plus the word itself. Right, so if, for example, if we had something called hello, master word was equal to empty string, and we add the length of the word, which the length of hello is 5, then we go ahead and add a hashtag. That's what this is right here. And then we go ahead and add the word. So in this case, the word is hello. And we just run this for each word. So the next word would be world. We get the length of world. And I think is this plus equals? Because we're kind of just adding it. Yeah. Okay, so plus equals, so we get the 5. Or, okay, in this case it's 5. So, we see that the length of world is 5, so we add 5. We add our delimiter, and we type in world. Alright, I think this should work, and now we can just return master word. Now we have to go ahead and decode the word. This is the bit tricky part. I guess we could go read. We know that the first letter is an integer. We don't know the length of the integer, so we can't just read just that symbol. You'd have to read from, I guess, from the left to the right. Wow. Okay, so I'm thinking we should have a pointer. We could have something called left pointer, which is initialized to 0. I think that should be good. We should have a right pointer, which is also initialized to 0. We could say while right pointer is less than equal to the length of, okay, so it looks like the word that we're given to us is an S. We want to return a list of strings. For now, let's go worry about this S. So it's length of S. Okay. And let's go ahead and say wow. Now we check if right pointer is not equal to our delimiter. Then we go ahead and increment right pointer. And now we could say, okay, so just keep on increasing, okay. Yeah, okay. So we just keep on increasing right pointer until it does reach a hashtag. And now we could assume wait, no, I don't know how this would work actually. Maybe we do something else. Wow. Pointer. See this symbol? The increased right pointer. How do you know if we're out of index though? Let's say and less than. Say length of S. We don't actually use the equal. Okay. Now we know after this. We know that the left, that the string left and right pointer is the length of the word. Right, we do.
Well, have a good day.
So we'll have something like this. Let me try to just type it out. Where is it? We'll have something like this. something like this, we're gonna have to figure out, how we would solve this. So I would say, let's just say some random ass number, okay? So left pointer would be right here. We had 1. Right pointer would increment all the way inside until it sees the hashtag. When it sees the hashtag, we know that it will be this size, so we'll iterate for that many times. Then right pointer. Oh. So we hit this. We can make, that's the right pointer is now a hashtag. Okay, I need to write this down in my notebook. Okay, what I'm thinking is that we can make left pointer is equal to right pointer, and increment right pointer by 1. I just have to find the right data structure to solve this. Maybe we don't have a right pointer. Yeah, maybe we don't have a right pointer. We do have a left pointer though. I'm gonna say for index and range length of S. Equal to pointer to index. Right? Is that good? Okay, let's see. I think this might be good. I'm gonna go ahead and write the case on my pencil. So trusty pencil in my notebook. Okay, so it's index equals this. Yeah, that is it. Now iterate for that. Okay. Now we get the word. Each letter in range, length, in just range size of word. We actually want to change it. Equal to index plus 1. This is going to be the first letter of the... Yep, yes it is. First letter of hello. At 1 increment. 5 times. Okay. We'll have something called result or answer. List of strings. Okay, now we can say answer stuff append. We append left pointer hello. Left pointer was at H. And we pointed like that. Okay. Now we change left pointer. Left pointer is now equal to index. Say plus equals. part of ledger. Oh, it could be out of range though. I think this should be it, man. I think we should be able to just return. I think this might be out of index though. Let's go ahead and check it. Check what we did wrong. Window. Oh. Support operand type plus for int-to-int string. Okay, let's go ahead and check it out. Size of word.
I've got to go.
Well, have a good day.
We have to make string. Make it a string. Answerless appends. Oh, it was just one hashtag. I guess this answer was actually pretty good. I didn't think of the case where the input was just a hashtag. I think in that case it would be 1, right? Let's say 4 or something. After you extract the word, your for loop keeps on moving forward by 1. Okay, so decode. J. Okay, let's see what's wrong with my decode. So, while pointers list the strings like this. Okay, that's what I did. Left pointer equals 0. That's what I thought too. Okay, for index and range length of S. Oh, we didn't do 4, we did while. I think I was trying to do a while loop earlier too. Index is equal to left pointer. Start at left pointer. Should I come up with myself? Okay, see, well, left pointer is less than the length. Yeah, because it can never go over. Length is equal to left pointer. Well, left pointers. Okay. I don't think I really get it, but I'm gonna just try to implement it and see if I get it. Increment index until it does equal wait, this down. Okay. Is equal to goes all the way up to index. Okay, now I got the This might be out of index. Okay. solved it. I don't know why this is not added.
I've got to go.
For example, we can hit word.
Well, have a good day.
C5. Length I chose 14. Okay. Okay, yeah, true. We scan until we hit that index is 8. So we got length is 5. 19 to 14. Okay. Okay. 9 plus 5, right? 2, 3, 4, 5. 9 plus 5 is 14. What the fuck? See. The left pointer would go out of bounds, but it doesn't matter because we short circuit anyways right here in the while loop. Also, we never try to access the 14th index, that's why you don't run into an issue. Okay, I think I understand this question now. Let's go ahead and do a review on what I learned from this. So encoding. I think encoding was pretty easy. I didn't really get lost or anything. It was pretty intuitive. I think right here, this double while loop is what I kind of had to learn, or what I learned from this. I was thinking of using a for loop instead. I think that would have been way harder. Yeah, using this while loop. This while loop I thought of. I didn't think of this one though, putting a nested while loop. Work on nested while loop got me confused, yeah. Same thing with this index equals pointer. Index is equal to pointer. Yeah, I think what I did is I made index. I kind of incremented it myself. Well, this index is equal to that. So we do this. So this, I think this one right here, this is to stop when we finish the whole word. This was to stop when we reach the delimiter. Left pointer. This was just to start this off. What if I do this? It'll work if I do this. I think this would work too, right? I think this would have worked. No. We keep on adding it, right? I gotta figure out this line of code. What is even the point? Start scanning from the beginning of the next encoded chunk. When it becomes 7. 1, 2, 3, 4, 5, 6, 7. Okay. So after finishing this, we worked it. Run this. I get it now. there from there. Yeah. Okay, I get it. All right, thank you guys for watching.